Today we begin with the maximal flow problems once again. If you recall, in our last class we just gave some introduction to the maximal flow problems. So, we have seen that maximal flow network, it is a simple connected graph, and I have also explained in the previous class that usually it is an weighted graph. Those in a flow network, most of these things are essentially flow capacities. Now, when in a network, the flow can be both sides, right? From suppose a node is I j, it could be from I to j or could be j to I. So, I to j we call it forward flow capacity and j to I is the backward flow capacity. So, both forward and backward flow capacities are possible. So, here if you look at that, most of the flow capacities are mentioned in terms of forward flow capacities and there is no backward flow. But there could be some exceptions. For example, look at 3 to 5. Here the forward flow capacity is 2, but there is a backward flow capacity also which is 1, right. Now, these are called transport networks, and the flow is from the source S to the sink T, and each arc has a forward and a reverse flow capacities. Previous day we have also discussed three broad assumptions, and obviously there is a fourth assumption also, that could be multiple sources and multiple sinks. So, what I said that you join the multiple source to a single sink called a super sink, and super source, multiple source to a super source, and multiple sinks to a super sink, and then carry on, and all these additional edges are going to have infinite capacity. Other assumptions are these node capacities are infinite, that means no restriction in this particular all these nodes. Then lossless flow, there is no loss of flow and no minimum limit for flow. So, these assumptions we have already seen. Today we start with a very important concept, that is called cut and its capacity. See, we have already seen the concept called cut set. So, let us take an example. Supposing, just take a very simple network. Let us say this is source, this is sink, and there are two more nodes here, node 1 and node 2. So, flow is in these directions, right. So, some flow is coming in here and the flow is going out of here. Now, S to 1, suppose capacity is 60, 90, 40 and 30. So, what are these? These are capacities of this flow. So, this is all unidirectional, that means here these are the forward directions I have shown. Now, what could be some cut sets, right? Look at, this is a cut set C1, this is another cut set C2, but you can also think of other cut set like C3 and C4. Obviously, there could be like this also C5. So, I hope you have you can see those cut sets. So, supposing let us use another pen. Supposing we name the edges, suppose this edge is E1, this is E2, this is E3 and this is E4. Then these cut sets C1 is E1, E2, right. Now, what is the cut set C3? C3 is E1, E3. Now, let us understand that how it looks after a cut set C1 operates. So, you see this is a cut set C1, it has how it operates. So, you see this is S, this is this portion and this is the other portion. and subsequently to T to F is this side and F is this side. So, you see this is where we have cut. So, you think this way that from S there is some flow that is taking place. Now, what will happen if we cut here, right? So, it is a cut set called C1. So, this is a C1 cut set. So, you see the material that goes will fall, right, because there is a cut, and since the flow water or whatever it will fall, it will not be able to reach sink. If it is still able to reach sink, then it is not a cut set, right, or to be more precise, cut in this sense. Let us take another example called, let us take C3. You see what happens in C3, the cut is actually here. See, this is C3. Now, tell me if some flow comes from S, can it reach T? Obviously, it cannot reach T through node 1, because node 1 is cut out by the cut set C3, but the flow can still reach from S to T. So, in that sense C3 is a cut set, but it is not a cut. It is a cut set, but not a cut. C1 is a cut set and it is a cut as well. So, look at the slide now. A cut set is a minimal set of edges whose removal leaves the graph disconnected. A cut also disconnects the flow network with source and sink in different components. So, in that sense a cut is a cut set, but not all cut sets are cuts. Additional requirement for something to become a cut is that after it operates, the source and sink should be on the two different sides, right. So, now tell me, is C1 a cut? It is all these C1, C2, C3, they are all cut sets, but is C1 a cut? Answer is yes, it is a cut, because it separates the S from the T, right. Flow will fall, if there is a cut here, flow will not be able to reach T, and if as if it is a cut, so they say it will bleed. All right. What about C3? It is a cut or not? Again it is a cut, because it separates the source from the sink. What about C2? C2 is not, because C2 does not separate source and the sink. So, if you say a cut set partitions the network or the graph into two different subsets or subgraphs, then source and sink should be on the source on one side, sink should be on the other side. If source and sink both remains on the same side, then it is not a cut. Now comes a very important concept, that is the capacity of a cut, right. Now, to express the capacity of a cut, we need to know that what a cut does. The cut partitions the nodes into two sets. What are those two sets? The P and P bar, right. So, look at the cut C1, it partitions the nodes into two parts. On one side is P, which is S, the other side is 2, 3, 4, 5, 6 T, right. So, this is P, set P is S and set P bar is 2, 3, 4, 5, 6 and T, all right. So, every cut then separates these nodes into two sets. So, obviously, can you now answer what are the two sets for C3, right? One side is S 2, 3, 4, 5, 6, all these nodes, and the other side should be T, right. So, that is the partitions that cut does. Now, you can well understand the capacity of a cut is therefore expressed as a function of both these P and P bar, and actually the capacity is written in the form of in the form of what is known as the P bar, right. And the cut set itself can also be shown as P bar. So, it is like if the cut set is P bar, then the capacity of the cut set is C of P bar. But interestingly, we know that the P bar is nothing but the rest of the nodes other than P, right. So, whatever nodes are there in P, the remaining nodes will be P bar. So, it is very easy, therefore, you simply write the P side of the nodes to express a cut set, that is the simplest way. So, if you simply write S, then S is partitioned, rest are on the other side. If you write S2, then can you see C2 is really S2, C2, because S2 on one side, rest of the nodes on the other side, and S2, 3, 4, 5, 6, S2, 3, 4, 5, 6. So, that is C3. Now, what is the capacity of a cut? The capacity of a cut is how much flow will go out of the cut if it actually operates. How much flow goes out, right? How much flow goes out. So, in this example, look at this example which we are talking about. In this example, what is the capacity here? The forward flow capacity is 6, and what is the forward flow capacity here? That is 4. So, what is the capacity of the here P cut set C1, sorry, cut C1, P is S and P bar is the rest, that is 1, 2, T, all right. So, what is the capacity of the cut? C1 P bar will be 6 plus 4, that is 10. Interestingly, one very important point one should remember, not all the time we may have to take the forward flow part, we might have to take the reverse flow also depending on the situation. Let us look at one more example. Supposing we have S1 to T and take this example. Let us take this example and compare this with another cut set, that is this one. So, you see this is C1 and this is C2, right. So, let us use different colors so that it is clear. So, you see this one is C2 and this one is C1. I hope it is very clear now. So, now there are different edges. So, this is E1, this is E2, this edge is E3, this is E4, this is E5. So, now the two cut sets C1 includes E2, E3, E4. And for C2, E1, E3, E5, E1, E3, E5. Again, for sake of simplicity, let us take only forward flow capacities and let us assume that there are no backward flows. So, what is the forward flow capacity at E1? Let us say 60, at E2 40, at E3 let us take 30, E4 40 and E5 70. So, you see when we are separating by C2, let us look at the cut C2, E1, E3, E5, right. So, what is happening? S and 2 on one side, 1 and T on the other side. So, first of all, there is a problem, this is not a cut. So, we modify C2. So, you see this is not a cut. So, we modify C2 like this, right. We modify C2 like this because S and T should be on the different side, right. So, therefore, C2, this is C2, this is C2. So, C2 should separate S from T yeah, that is fine, it is fine. S and 2 on one side, 1 and T on the other side, no, it is fine, no problem at all, no problem. So, this is C2, there is, let us put a different color. So, yeah, so this is C2, no issue, S and T on the other side, right. So, now look here, what will be the capacity then, right. So, here this is also cut. So, this is the cut C2, right, this is the cut C2. So, look at this cut C2, suppose you want to find its capacity, then from S to 1 what is the flow? The S to 1, this is the cut C2, S to 1 the flow is 6. What is the flow from 1 to 2? 1 to 2 the capacity maximum is 3, but what is the 2 to T? The 2 to T the flow could be 7. So, what is the C P bar, in this case that P is S2. So, P bar, let us write P bar for C2. What will be C2 P bar, where P is S side, that is S and 2, and P bar is the 1 and T. What will be its capacity? What will be its capacity? So, look here, how much flow can pass from S to 1? 6. How much flow is 2 to T? 7. No problem at all. But what about 1 to 2? The 1 to 2, the maximum flow is 3 only, is it all right? 1 to 2 is 3, but in this case the flow is cut from 2 to 1, not from 1 to 2, because 2 is on the S side. So, we really do not need to take 1 to 2 capacity, but 2 to 1 capacity, which is 0. So, it should be therefore 6 plus 0 plus 7 equal to 13. So, I hope you understand that if sometimes, but on the other side, if you look at S1, then this is S1 and this is 2T. So, S to 1 there is no problem, 1 to T it is separated, 1 to 2 it is separated, and S to 2 it is also separated. So, this is the separation. You see S and 1 on one side, 2 and T on the other side. So, this is the cut C1. So, this is the cut C2. So, when there is a C1 cut, then 1 to T the capacity was 4. So, 4 was coming here, 1 to 2 the capacity was 3, and S to 2 capacity was 4. So, C1 P bar would be 4 plus 3 plus 4, that is 11. So, I hope you understand that how you look at such kind of node capacities. So, here look at this example, there are 3 carts C1, C2 and C3. So, what would be their capacities? If you look at C1, then it is very simple, S is on one side and rest of the nodes on the other side. So, it should be 9 plus 6 plus 2 17, no problem. When it comes to C2, it separates this and this. So, here capacity was 8 because you see S and 2 on one side, 6 and T on the other side. So, very simply they are all cut in the forward way. So, it should be 8, 6 and 2, total is 16, that is the capacity. And what is the capacity of C3? Because it cuts this 5, that is from 5 to T and 6 to T, it should be 17, right. So, these are the capacities of the cut for this particular network, right. But interestingly, this is an interesting example. What will be the capacities of the cut C4 and C5? That note is whatever I was trying to tell you, its note is given here. Always look for source to sink flow through the cut, right. So, if you look at the source to sink flow through the cut, what is the capacity of C5? Because look at the 3 4, the 3 4 the capacity is, the 3 to 4 is capacity is 4, but 4 to 3 capacity is 3. Similarly, 3 to 5 is 2, but 5 to 3 is 1. So, what is the capacity of C5? Look here, then this is one portion and the other side is the other portion. So, what happens? These portion when you separate, then 5 to T, the flows are taking place from source side to sink side is 5 to T, 3 to 6, 3 to 4 and S to 4. That is what happens in cut C5. So, here the forward flow capacity should be taken, here also forward flow capacity, here also forward flow and here also forward flow. So, total comes to the 5 plus 5 10 plus 4 14 plus 2 16. So, that means the capacity of the cut C5 would be 5 plus 5 10 plus 4 14 plus 2 16. But what is the capacity of the cut C4? Capacity of the cut C4, if you really look at the cut C4 separates S2 and 5 on the other one side and 3 4 6 and T on the other side. So, since 3 on the other side, then the flow has to be taken from 5 to 3. So, you see interestingly, very you can write down in a very interesting manner. You see the cut is S to 5, that is the cut. So, basically P is S to 5 and P bar is the rest. So, what are the rest? Rest are 3 4 6 T. Look here. So, you can then understand, if you compare, then you see P to P bar flows, you do not have to draw the diagram also. P to P bar flows, what are the different combination? There could be 12 combination, but not all 12 combinations are available. If you look at here, S to 4 is available, S to 3 is also available, but S to 6 is not available, S to T is also not available. So, out of them, what are the things they are available is S to 3 is available, S to 4 is available, then 2 nothing is there, no arc is there from 2 to this, and from 5 5 to 3 is available and 5 to T is available. Look here, S S S 5 5 3 4 60 on the other side. So, these are edges, you can call them P bar edges, P to P bar edges, P to P bar edges. So, again look here, just look this slide, you can see that the S 2 just please look at the slide. So, S 2 4 and S 2 3, these capacities are 6 and 2 8, but 5 to 3 capacity is 1, right. We do not have to take 3 to 5, we have to take 5 to 3. So, because we have to count 2 plus 6 8 plus 1, that is 9, plus 5, that is 14. So, the capacity of the cart is really 14, right. Capacity of the cart is really 14. So, that is how you have to compute the capacities of the cart, and there is a very important theorem that is called the maximum flow minimum cart theorem. This theorem states that in a flow network, the maximum value of flow from source to sink is equal to the minimum value of the capacities of all the carts in the network that separates source from the sink. So, if the capacity of cart is C, only capacities from S to T should be considered. Obviously, that is already known about cart, right. Some people it is not maximum flow minimum cart set, it is the maximum flow minimum cart, and cart is separate from cart set. A cart is nothing but a cart set that separates source from the sink. Is it all right? So, if that is so, then the maximum flow minimum cart theorem basically says, if you look at this network, what is the maximum flow that is possible from S to T. So, out of all the carts, so basically you have to look at all the carts, and taking all the carts, you have to then understand what is that cart which is giving me the minimum capacity. It is the maximum flow possible. It is like the simple bottleneck theory that maximum flow is possible, a chain is like say as strong as its weakest link, that is called theory of constraints, right. Same thing happens here, for a flow, a maximum flow is possible only that much which is the minimum possible cart. So, what is the minimum cart here? We have seen different carts. What is the capacity of this cart? This will be 17. This cart is 8 plus 6 plus 2 16. This cart 15. This cart 17. So, what is the minimum? Interestingly, go back one slide. We have seen a cart C4. See the cart C4. What is the capacity that we have computed? This side is 5, this side is 1, this side is 6 and this side is 2. That means 5 plus 1 6 plus 6 12 plus 2 14, right. So, there is a cart C4 we had already found whose capacity was 14, right. Now, look at this graph. Here a flow of 9 can go, flow of 6 can go, flow of 2 can go. So, it looks as if a flow of 15 can pass through this network, because there is no limit here 17, there is no limit here 14, apparently it looks that 15 is possible, but really 15 is not possible, because there is a cart here from here to here to here to here to here, is all right, and this cart is capacity is 14. So, look at this graph once again, there is C4 and its capacity is only 14. So, maximum flow that is possible in this particular network is only 14, right. So, this point has to be remembered, that maximum flow that we can have at a given this thing is given by the minimum cut. So, thank you very much.